Welcome, and thank you for choosing to watch my presentation. My name is Ken Hackbarth, and my presentation will demonstrate the value of 3D printed assistive technology and why 3D printed keyguards are the best way for you to get started with this new technology. Email me and I'll send you a copy of this presentation with notes. Remember, there are two S's in Volkswitch. On this slide, I've tried to represent my proposal as a picture, and at the same time call out the two arguments that I need to convince you of. First, I need to convince you that there's a wealth of high-value, freely available, 3D printable assistive technology designs that you can take advantage of right now. Even if you already believe that, you may believe that there is an impenetrable technological and financial wall between you and those devices. My second goal will be to convince you that there's a gateway through that technological and financial wall called 3D printed keyguards. But first, a little context. Let's all get on the same page as to what someone means when they use the words 3D printing. The simplest definition of 3D printing that I can think of is 3D printing takes a digital model and layer by layer turns it into a physical object. A digital model is a virtual object created using specialized software called computer-aided design or CAD software. In this example, someone has created a virtual rabbit wearing sunglasses. That digital model is then sliced into a series of horizontal layers by another piece of software called, of all things, a slicer. The slicer then tells a 3D printer to print each layer on top of the previous, starting at the bottom. A 3D printer uses thermoplastic filament or photosensitive resin to create the final physical object. The instructions can be repeated over and over to create additional copies. I'm going to quickly cycle through several examples. Each example will include a picture of the device and the cost of the plastic required to print one. The title of each slide includes a hyperlink to the 3D model. Remember, if you send me an email message, I'll send you a copy of this presentation with notes, including URLs. Here's a compilation of some of the best sites to visit if you're looking for AT designs. The first two sites are repositories of 3D models in general. You need to search specifically for assistive devices, but they have hundreds of designs. The remaining sites focus entirely on assistive technology. If you get into modeling AT, I encourage you to post your designs at least to Thingiverse and Makers Making Change to share with others. I hope I've piqued your interest regarding what's possible with a 3D printer. What's the quickest and easiest way to get there? I believe the answer is 3D printed keyguards. I'm sure that many of you are already familiar with keyguards. For those who aren't, a keyguard is a plastic plate that sits on top of a keyboard, or now, much more often, a tablet. The plastic limits access to only those places where openings have been cut in the plate. Keyguards help people with limited fine motor control to more effectively interact with the app on their tablet. They also allow people who are easily fatigued to rest their hand on the tablet without triggering some action within the app. They can make a huge difference in the user's productivity. How many keyguards do you need? That will depend on the number of tablets and apps you use or recommend, how many ways the apps can be configured, and how many tablet cases you may use, now and in the future. If you only recommend 2 different tablets, each in 2 different cases, running 2 different apps, and 4 different configurations for those apps, you will need 2 times 2 times 2 times 4, or 32 evaluation keyguards. If a quarter of those break or are lost over time, you'll need an additional 8 keyguards for a total of 40. Users will need new keyguards as their skills improve or degrade over time. And there are bound to be new tablets, cases, and apps in the future. I know what you're thinking. You're thinking that there's no way you could possibly afford 40 keyguards, so that's simply crazy. But would it be crazy if you could cut the cost of a keyguard by 99%? I designed and printed evaluation keyguards for an SLP at Imagine, Colorado. They support 2 different tablets, one of which could be placed in 2 different cases, just one app, Go Talk Now, and 4 possible layouts of the app. She needed a total of 10 keyguards to perform evaluations. How much does a commercial keyguard cost? Here's a page from the Keyguardat website. Keyguardat is the largest producer of laser-cut keyguards in the US and possibly globally. I purchased a keyguard for them for the TouchChat app running on an iPad 2, and the final cost was $71. Logan Tech sells keyguards for their systems, and this one costs $149. So what if I designed and printed that TouchChat keyguard myself? Let's take a look at how easy it is to design a 3D printable keyguard. I've downloaded the free OpenSCAD and free Keyguardat programs from the web. Complete instructions can be found on the Volkswitch website. When I launch the two, I see a screen like this. On the left is a depiction of the keyguard as currently specified. On the right are a set of expandable sections with options for customizing the design. I'm going to design a keyguard similar to the one that I purchased from Keyguardat. First, I'm going to specify the tablet. In this instance, an iPad 2. I can choose to expose or hide the camera and home button, but I'm going to leave them exposed. I can also swap the location of the two, and that might be necessary depending on the tablet's case. A detailed explanation of all the options and their implications for the design can be found at the Volkswitch website. Next, I'll specify the layout of the TouchChat app. I'll specify the heights of various components of the app. I can take the measurements using a metric ruler or by counting pixels in a screenshot. According to my measurements, the status bar and the upper message bar are a combined 11 millimeters in height. Note that the picture on the left updates with each change so I can immediately see if I've made a mistake. The upper command bar is 9 millimeters in height. I'll expose the message bar but not the command bar. There is no lower message bar or command bar in the Touch Chat app, so I'll leave these unchanged. I can provide easier manual and visual access to the message bar by changing the bar slope from 90 degrees to 45. This is only possible because we will be 3D printing the keyguard. This is not possible for a laser cut acrylic keyguard where every cut is at 90 degrees. Now we'll lay out the grid area. The app will have 5 columns and 5 rows. I could widen the rails between the buttons and change the slope of the rails. Again, laser cut keyguards can only have 90-degree cuts. I can change the shape of the openings from rectangular to circular, or from circular to rounded rectangles. And I control how rounded those corners will be. But let's go back to a simple rectangular openings, since that's what I ordered. I have the option to cover certain cells in the grid or merge them both horizontally and vertically. I can make fine adjustments to the location of the rails by adding padding, but that's not necessary with the Touch Chat app. We're almost done. The last thing we need to do is settle on the mounting method for the keyguard. If I'm not using a case, I have the option to use suction cups, in which case cuts are made to accommodate the top of each suction cup. I can go with Velcro, in which case recesses are added to the underside of the keyguard. I can go with screw-on straps that I purchased from Keyguardat, in which case cuts are made to accommodate those straps. I can go with clip-on straps and 3D print the clips. Finally, I can use micro-suction tape, in which case I don't need any special mounting features. But it's rare that a tablet doesn't go into a case. The keyguard I purchased from Keyguardat was going into an AVAWO Kids case. So let's go to the tablet case section and tell the program that we have a case. We now have to tell the program the size of the opening in the case, since that's what determines the overall size of the keyguard. The opening of my case is 163 millimeters high and 215 millimeters wide. It also has rounded corners with a 5 millimeter radius. Now we'll look at the options for mounting this keyguard in a case. I can still go with clip-on straps and print my own clips. I can choose the traditional slide-in tabs. And finally, I can go with raised tabs. This may be my best choice for a hard-sided case with a screen protector. But my case is soft-sided, so I'm just going to wedge the keyguard into place, so I'll choose No Mount. My design is ready to go, so I'll tell OpenSCAD to render my design. Lastly, I'll tell it to export my design as an STL file. The next step is to print it. And how difficult is it to 3D print a keyguard? This video is going to show you how you take an STL file and turn it into a printed keyguard. So we produced an STL file from OpenSCAD, and now we're just going to take it, drag it, and drop it into our slicer. In this case, I'm using the Prusa edition of Slicer. You may be using an entirely different slicer program for your printer. The first step in this program is to slice the model, and then you're just going to export the G code. This is the language that the printer understands. And I'm going to put it on an SD card. That didn't take very long, so it's now on the SD card, and we can load the SD card into the printer. The SD card is loaded. The printer is about to begin printing the keyguard. It'll take about 4 hours to print the entire keyguard. Printer is going through a leveling process, and then it will begin printing. We won't see the entire print because 4 hours is a long time, but we will come back eventually at the end to take a look at the finished keyguard. Alright, it's time to remove the keyguard from the build surface. So we'll take it, crack it, take it off. So there we have it, finished keyguard. Alright, time to see how our new keyguard actually fits. What we're going to do is we're just going to wedge it right into the case. There it is. Nice fit all the way around. And it's just not going to come out, but you can pull it out quite easily and swap in a new keyguard. All of that for about $1. How much did it cost to print that keyguard? Well, it depends on how much plastic filament was used. This is a screen capture from the slicer program. If you tell the slicer how much you pay for a kilogram of filament, the program will tell you how many grams of filament your print will require and will calculate the cost of the print. In this example, the keyguard cost me 97 cents. Let's look at the kinds of keyguards that are possible to create with the Volkswitch Keyguard Designer. Here are a collection of keyguards, all of which were designed with the Volkswitch Keyguard Designer. They're roughly organized into grid-based keyguards, hybrid keyguards, and freeform keyguards. The hybrid keyguards are a hybrid of grid-based with some freeform elements. We'll take a closer look at these keyguards next. Here are our first set of grid-based keyguards. They're all designed to fit directly on the surface of a tablet without a case. You'll notice that they could be in portrait or landscape mode. This keyguard is held in place by microsuction tape, which holds very well to the glass of the tablet without leaving any residue behind. It can be applied and removed multiple times. This keyguard is using clip-on straps. Remember, you can print your own clips. This keyguard uses Velcro, and this one uses suction cups. More keyguards, some that use multiple colors of filament for interest, for personalization. You can see both the slide-in tabs as well as raised tabs. Here's just another example. It shows you how many holes can be in the grid without any problem in printing. These are both clip-on straps, and under certain circumstances, like with soft-sided cases, you don't even need the straps in the back for them to hold tight. You can even use these clip-ons with keyguards that have screen protectors and leave very little space between the edge of the screen protector and the edge of the active area of the screen. A freeform keyguard simply takes a piece of plastic and punches holes in it of a variety of shapes wherever they are needed. So this is just a keyguard supporting a standard email app on an iPad. And this keyguard supports the Acorn AAC app, which uses a very different algorithm for producing phrases. And it has a very specific layout for that purpose. Again, in this case, the program is told where every hole should be, what its size should be, what its shape should be, and you're able to produce an arbitrary keyguard using that logic. These are all hybrid keyguards, meaning that they're based fundamentally on a grid of openings, but they also allow for openings to be made outside of the grid in very specific locations. So this is a keyguard made for Go Talk Now, so is this one. These two show cutouts made in the message bar for a couple of menu items in the Touch Chat app. This one shows that you can add raised features as well, buttons like that, or walls around a cell, or little walls that lead to another location. And it also demonstrates the merging of cells and the covering up of certain cells. Another nice feature is you can add text engraving to a keyguard on top, and I don't know how well this shows up, but here's a serial number on the underside of the keyguard. And lastly, you can do some clever things with color again, using multiple colors of filament. And this also demonstrates a feature of printing keyguards on smaller than the largest build surface. So I can add a dovetail joint at some point in the keyguard and use that joint to bring two pieces together that were printed separately. Depending on the tightness of the joint, you may not even need to use some kind of adhesive. This is also a hybrid keyguard, but I bring it to your attention just to show you that you can print very large keyguards on smaller size printers, but they have to be printed in two parts and then joined together. You may recognize this as an Accent 1400 keyguard with special case additions added so that you fill in all of the open space in the case. Then you take these two, you overlap the dovetails, a little light tapping, and you've got a keyguard that really actually isn't going to come apart. But you would have otherwise had difficulty printing this on a printer even as large as 300 millimeters. I hope I've created some excitement for you around the idea of getting a 3D printer. If so, let's take a look at some options. A high-quality 3D printer may be much cheaper than you think. I've owned several 3D printers over the last 3 years, and here are my two current favorites. The first is the Artillery Sidewinder X1, which sells for around $450. The second is the Prusa i3 MK3S, which you can get in kit form for $750 and fully assembled for about $1,000. By the way, I highly recommend assembling your printer from a kit when you can. What you learn in the process will make you more confident when you encounter issues in the future. The Sidewinder has a 300mm by 300mm build surface, while the Prusa has a 250mm by 210mm build surface. If you think you'll be making keyguards with your printer, I recommend that you purchase one with a build surface that's at least 250mm on one dimension. Both printers are more than capable of printing keyguards. How can you justify purchasing a 3D printer? Well, if you save on average $90 for every keyguard that you print rather than purchase, you can justify the cost of a 3D printer in as few as 5 to 10 keyguards. Once you have a 3D printer, you can begin to explore the full range of free, pre-designed assistive technology, along with designing and printing your own solutions, which could lead to even more cost savings. How difficult would it be to use this information to put together a business case? What if the barrier is still too great, or maybe you're not ready to make that kind of commitment? How can you get access to 3D printed AT without a 3D printer? If you're employed in a school district or even just a member, many districts offer STEAM and STEM programs. These middle school and high school STEM classes often have 3D printers that are sitting mostly idle. You can give the teachers and students a reason to dust off those printers and CAD software to produce devices that will change people's lives. There are several online companies who will print your design. Thingiverse supports submission of designs to 3 different services. I sent my TouchChat keyguard design to all 3 to find out what they would charge. The prices vary somewhat, but on average represent a 2/3 savings over purchasing the same keyguard from Keyguardat. You may also have a local library with a 3D printing service. This library is located a few miles from me, and they charge just 10 cents per gram to print a design. Remember that my slicer program told me the TouchChat keyguard requires 40 grams of filament. That's a total of $4 for a keyguard, and I didn't have to purchase or maintain the printer, nor did I have to purchase and store the filament. This eye chart is a listing of Facebook groups that focus on 3D printing in general, the Prusa line of printers, and the Artillery line of printers. Most of the people in these groups are excited about 3D printing as a technology, but they're tired of printing Yoda heads and baby Groots. Their shelves are full of decorative items and they're wondering if that's all there is to this technology. If you post to a few of these groups and describe your need, I guarantee you'll hear from someone who's dying to finally use their printer to create something of real value. You may need to reimburse them for the filament and postage, but then again, you may not. Are you a member of a parents group? Could the members of the group pool their resources and purchase a 3D printer and filament? I suspect that every parents group harbors a father who'd love to do the research, purchase and house the printer, and even become an expert in its use. Time for a couple of final thoughts. If you're planning to create some 3D printed keyguards, two of the most important measurements are the height and width of the opening in the case. Unfortunately, it's very hard to take these measurements accurately with a ruler. We've created a 3D printable tool, our Easy Measurement Tool, expressly designed for this purpose. How much does it cost? Well, if you email me and request an Easy Measurement Tool, I'll send you one for free. At this point in the presentation, I'd normally open the discussion to questions from the audience, but since that won't be possible, I'd like to encourage you to send me your questions. I really want you to be successful, so don't hesitate to contact me.
Come here. Give kiss.
Thank you.